The heated metal billet is first pressed into a rough circular shape using a forging press. Then, a central hole is punched through the middle using a specialized machine. The ring is transferred to a ring rolling machine where its diameter is expanded and the wall thickness is reduced uniformly. After that, the ring undergoes a final pressing stage to ensure precise dimensions and roundness. Finally, the ring is cooled down, inspected for quality, and transported to storage or the next processing stage. The Mr. 1 is a powerful CNC machine capable of removing 30 pounds of steel per hour with high precision. It efficiently machines aluminum, steel, titanium, and stainless steel, making it ideal for both prototyping and production. Located in Altenmarkt, this state-of-the-art industrial site develops and manufactures machining centers and special-purpose machines. A highly qualified team uses finite element modeling to run dynamic simulations early in the design process. The in-house iron foundry produces 120 tons of blanks per month for in-house machines such as drilling columns, vertical drilling machines, and machining centers, along with an additional 480 tons of castings for customers. The castings, ranging in weight from 100 grams to 3,000 kilograms, are primed, painted, and machined using state-of-the-art CNC tools. A flexible production cell handles heavy parts, while automated tool changers and assembly systems streamline production. From spindle assemblies to control systems, all components undergo rigorous testing and adjustment. High-speed milling, threading, and digitization of free-form surfaces are carried out with precision. The company invests heavily in employee training and apprenticeship programs to ensure long-term expertise. With over 200,000 machines in continuous operation worldwide, it reflects the perfect combination of traditional craftsmanship and modern technology. The production of metal chessboards and pieces begins with design and installation. This equipment plays an important role in fixing metal components, such as frames and chessboard squares, during various machining, polishing, and assembly processes. The clamping system is carefully designed to apply even pressure, preventing any damage or scratches to the metal while ensuring accuracy and alignment. Materials such as rubber-coated metal or plastic are used to create clamps, which protect the surface of the components. The next step is to create the squares on the chessboard. Large sheets of metal are cut into squares of precise dimensions to ensure a uniform and symmetrical chessboard layout. These squares are then coated with a contrasting color, using methods such as electroplating or spray painting, usually black and white or white and gold. This coloring process not only enhances the aesthetics of the board, but also ensures durability, as the coating forms a protective layer against wear and tear. In the case of using different materials for the squares, such as metal and wood, an adhesive is used to firmly bond the squares to the board frame and wait for 4 hours. This adhesive is carefully selected to ensure strong adhesion and durability over time. Once the squares have been firmly placed in place, the polishing and grinding process begins. The surface of the board is smoothed to remove any rough edges or imperfections. Great care is taken to ensure that all the squares are perfectly aligned and the edges are sharp and clean. After polishing, the board surface is treated in detail. This may include engraving logos, decorative patterns of the chess characters using CNC machines or laser engraving technology. Meanwhile, the chess pieces are produced by automatic CNC machines to ensure uniformity in size and shape. After the pieces are created, the base is manually glued with magnets to ensure stability. Finally, all chess pieces are quality checked, ensuring that the chessboard and chess pieces meet high standards of craftsmanship, durability, and aesthetic quality. The finished product is then ready for use. Roll forming is a metal manufacturing process in which a continuous coil of metal is passed through a series of rollers to gradually shape it into the desired shape. At Steel Forming Systems, the process begins with the selection of the appropriate material, steel, aluminum, or stainless steel, before it is uncoiled and passed through a pre-formed punching die to add notches, slots, and holes. The material then passes through a series of rolling dies that slowly shape it into its final shape with minimal stress. The part is then cut to the desired length and thoroughly inspected for quality. Latest subsea testing of Irisar products is ensuring 100% sealing, meeting the requirements of the oil and gas industry in harsh environments. The slab caster at Puyang Steel, supplied by SMS Group, integrates a specialized ladle car for ton discharging. The process involves precise control over molten steel, ensuring high surface quality through hydraulic resonance oscillators. Advanced cooling systems and dynamic control ensure uniform cooling and exceptional slab properties, resulting in a smooth production run with high-quality slabs. The Optisize concept by Schneider Form GmbH offers quick maintenance and simple handling, optimized through a well-thought-out modular system. Key features include easy steps for maintenance due to the modular design, with the matrix easily lifted from the core side. The removal of sliders is carried out without additional effort for temperature control, ensuring simple inspection of the sliders. Optimized interfaces ensure error-free maintenance while all functions are accessible and can be thoroughly checked. The system's design allows for hassle-free disassembly, and years of experience have led to mature, high-quality solutions. Continuous development further enhances its reliability and performance. The 42 Big Motor Coil Inserting Machine is a highly advanced industrial machine designed for the efficient insertion of coils into large motors. This machine offers precision and speed, ensuring that coils are inserted accurately into motor stators or windings. It is equipped with advanced control systems for easy operation and can handle large-scale production with minimal downtime. Ideal for the manufacturing of high-performance motors, The machine enhances productivity and reduces labor costs, making it an essential tool in modern motor production lines. The Froreap drill has had its spindle adjusted to match the performance and speed even with the internal cooling system. In addition, the control system has been updated and the guide rails have been completely overhauled. The MO4 tool is designed for creating decorative forged parts, baskets, and twisting square bars or strips. It is easy to use and does not require prior forging skills. The tool allows for making baskets by twisting 4 workpieces around an axis, followed by assembly and welding to complete the basket. Vertical twisting is performed over a 500 mm section with a one-sided release action. The delivery includes 2 sets of shafts for making baskets from 6 by 6 mm and 8 by 8 mm square bars, 2 guides for assembling parts into a basket, and a shaft for vertical twisting of square bars. The tool works with materials such as 6 by 6 mm, 8 by 8 mm square bars, and U6 bars. The FC bus production line begins with the construction of the frame and chassis, which includes using high-strength steel or aluminum for structural integrity while keeping the weight low. The chassis is assembled with key components such as suspension, axles, and areas for mounting the fuel cell system and electric motors. Next, the fuel cell stack is integrated into the bus, with hydrogen storage tanks securely mounted. Power electronics, controllers, and inverters are installed to manage energy between the fuel cell, batteries, and motors. The electric drivetrain is connected, followed by the installation of the battery pack. The fully integrated aluminum recycling system includes TRF5 inclined rotary furnace, Reverber 5 inclined rest furnace, conveyor casting horse, and deoxidation casting line, ensuring efficient recycling and improved product quality. SCN Machinery's deep draw press is designed for processing various metal parts, such as car body and electronic components. The machine capacity ranges from 100 to 3,000 tons, and the table size ranges from 800 by 700 millimeters to 4,500 by 3,000 millimeters, with safe control system, high efficiency, and easy operation. The production process of stainless steel begins with collecting scrap metal, including old items like sinks and pots. The scrap is fed into a furnace, where nickel and chromium are added to enhance strength and corrosion resistance. Under the action of large electrodes, the metal mixture is heated to extremely high temperatures, creating a spectacle similar to fireworks. After heating, the metal is cleaned in a furnace with argon and oxygen to remove impurities. The molten metal is then cast into flat sheets, which are further processed by rolling. These steel sheets are cooled, cleaned with hot acid to remove rust, and then cold rolled to achieve the desired thickness. Finally, the steel is polished and cut to customer specifications, resulting in shiny, durable stainless steel. Spirit AeroSystems manufactures leading-edge aerospace structures, including fuselages, wings, engine pylons, and engine nacelles for commercial, defense, and corporate jets. They specialize in advanced aluminum and composite fabrication, providing high-quality products to the global aerospace industry. The modern spring manufacturing process is fully automated with high precision. The steel wire is fed into the winding machine to shape according to the type of spring: compression spring, shaft spring, tension spring, or torsion spring. The shape is shaped by shafts and automatic guide mechanisms. After winding, each type of spring has its own requirements for shape, elasticity, and precision, meeting many fields such as automobiles, industry, household appliances, and medicine. Jetstar's first Boeing 787 Dreamliner was assembled rapidly at Boeing's Everett facility in the U.S. Major components such as the forward fuselage, center fuselage, wings, and tail were transported by the massive Dreamlifter cargo aircraft. Thanks to a modular production process and high automation, final assembly took only a few days. Once the airframe was completed, systems like avionics, flight controls, and cabin interiors were installed simultaneously. After thorough quality inspections and successful test flights, the aircraft was officially delivered to Jetstar. It now serves long-haul routes, offering passengers improved comfort, fuel efficiency, and advanced technology. At Sunny's Super Drilling Machinery Factory, the MX350 robot, flipping positioner, bearing press robot, oil seal press, and tightening machine all work together to ensure precision, efficiency. The 60-ton center lathe has an 8-foot chuck with a 28-foot distance between the chuck and center and a center height of 7 feet. GL105, designed for complex tasks like crane hook machining, ensures that the hooks meet the highest standards of quality, safety, and performance, providing reliable and efficient operations in demanding environments. Fonderia Tironi, founded in 1974, specializes in high-energy aluminum castings and has built a long-standing tradition in the production of high-quality aluminum parts. The process begins with an advanced 3D mold design developed in collaboration with the customer, followed by continuous monitoring of the production stages off-site. The raw aluminum is then heated in a furnace to the appropriate temperature, allowing the aluminum to harden and remove impurities. Once the aluminum has reached the required temperature, it is manufactured into a precisely designed kinetic object to create aluminum parts. This casting process uses advanced technologies, such as an automated casting system with humanoid robots and dynamic grinders, which ensure safety and efficiency in production. Once the aluminum has solidified in the sample, the product is removed and subjected to additional processing steps, such as grinding and testing for strength and durability of the needle using modern analytical equipment. Each stage in the aluminum gravity casting process at Fonderia Tironi is FAT-controlled according to EN-UNI ISO 9001-2008 standards, ensuring that the product is always of high quality and meets the rich requirements of customers. The installation process of the inner casing for the 717 megawatts LP steam turbine at Maptaput is a critical step requiring high precision and strict control. First, all contact surfaces are thoroughly cleaned and inspected to ensure no dust or deviations. Then, the inner casing is lifted using a specialized crane system and carefully aligned to the predefined position. Positioning bolts and alignment tools are used to ensure concentricity and balance. The entire procedure is carried out under the supervision of experienced engineers and technicians to ensure safety, reliability, and long-term operational efficiency of the turbine system. The metal spinning process for creating a nose cone for a wind vane involves forming a flat metal disc into a conical shape. The disc is placed on a spinning lathe and rotated at high speed. A roller tool, either manually or automatically operated, gradually presses the metal against a mandrel that defines the final shape. Through consistent pressure and smooth movements, the metal conforms to the mandrel, creating a seamless and precise nose cone. This method ensures structural strength, aerodynamic efficiency, and a smooth finish. Metal spinning is ideal for producing lightweight and durable parts, especially in applications requiring high precision and performance like wind vanes. Tri-State Wire Rope performs professional splicing on 1-1/2 wire rope, a process requiring precision and strength. It begins with unlaying the rope strands, weaving them back into the main body, and securely tucking them to form a strong, continuous loop. After splicing, any excess length is carefully sawed off to ensure a clean finish. The rope is then fitted into a custom fabricated steel frame or thimble to reinforce the splice and maintain structural integrity under load. This additional step enhances durability and ensures the splice can handle demanding applications in lifting, rigging, and construction. Tri-State's skilled technicians uphold the highest standards of safety and performance. The Rockwell hardness test measures the fixed depth of indentation of a hard object under test force. The depth of indentation is measured to calculate the hardness. This 20-ton machine is designed for soldering cable ends made of aluminum and copper and has an integrated pre-machining unit for milling the faces, ensuring oxide-free interfaces. The yarn process in ring spinning begins with raw cotton, which undergoes several stages to transform it into a single yarn. First, the raw cotton is fed into the blowing section, where impurities such as dirt and seeds are removed, and the fibers are separated. After this, the cotton is moved to the carding process, where the fibers are further straightened and formed into a sliver, a continuous strand of loose fibers. Next, the sliver is passed through the drawing process, where it is elongated and blended with other slivers to ensure uniformity in the fiber length and thickness. The sliver is then combined into a finer form, known as roving, during the roving process. This creates a thinner, more elongated strand of fibers which is ready for spinning. In the ring spinning stage, the roving is twisted into yarn using a spindle. The spinning process imparts strength and consistency to the yarn by twisting the fibers together. The yarn is then wound onto bobbins in the winding phase, ensuring the yarn is neatly coiled for further use. The final product is a single yarn that is smooth, strong, and ready for weaving or knitting into fabric.